Hello YouTube, this is Jessica from STEM APKs. Welcome to another tutorial. In this tutorial, we're going to continue where we left off in the last tutorial. As you remember, in the last tutorial, we were working with PPM files, and I show you how to create PPM files from scratch, how to create synthetic images, and how to also, I also show you how to create a command line interface tool where you are able to read and to visualize what a binary file looks like coming from a PPM per pixel, 3 bytes per pixel, RGB. If you watch my last tutorial, you know exactly what I'm talking about. In this tutorial, we're going to take everything that we learned in the last two tutorials with PPM files and why do we spend that time learning about them, because we're going to be using them as intermediary files. Whether those files are found on an embedded system, uh, or a Raspberry Pi, or a BeagleBone, or any other thing out there, or how to transfer them from the device, from the embedded device into our computer, and also from our computer onto the device, onto the Raspberry Pi or whatever it is. There are other mechanisms to do that. For example, if you have been doing some work with Unix-based systems, you know about, and also actually Windows also uses SCP, I believe. The Secure Copy Protocol. Secure Copy Protocol is going through SSH, and most of the times, I believe, yes, it's using the port 22. So it's basically a secure copy protocol is not really a part of the transport because it's using SSH as the transport. A lot of times, secure SCP, I use SCP all the time. Other people that I'm dating myself now, but we used to use FTP a lot back in the day. A lot of that stuff, there are many other alternatives, but sometimes you're not on a network, and that's now you have to be dealing with other ways to get your data and transfer your data. Sometimes you are behind a NAT, and for those of you that don't know, this is the NAT table that maps all the IP local IP addresses. Sometimes you're behind one of these NATs and it has no public IP address, so you cannot really communicate to the world. Sometimes you're doing networking, sometimes you're doing other stuff that you need to TCP forward, port forward. This is not a networking class, so I don't want to get too into it. But for those cases, you need an alternative to using SSH, or you need an alternative to most of the things that we use all the time. This tutorial is for those cases. So basically, we'll be using SOCAT, and I believe socket is called socket something. I forgot what it is. But basically, for those of you, um, there's also Netcat, and I've used Netcat a lot. And SOCAT is also, it gives more, I think is more robust in certain situations, but there's cases for both. But basically with SOCAT, you can use files, you can use pipes, you can use serial line. We're going to be doing some serial stuff, some cool stuff, file descriptors, and other stuff. And if you remember, if you watch my a couple tutorials ago, I talked about this book. And if you want to learn more about FIFOs, they're right here. We're going to be using what is called FIFO. Sometimes you're going to be calling it a name pipe. You can send data through computers, through a Raspberry Pi using these tools. And one tool that makes it possible in order to do that is SOCAT. and that's what we're going to be doing. So let's see how we're going to do that. The first thing that I'm going to do, I'm going to open the code here. And basically, you're going to have two files. You're going to have, in my case, I have a listener on it. Right now, I'm going to be using bash and script. And so you see how easy it is using batch, and then we're going to incorporate it using Rust and using PuTTY and making it look really pretty using a graphical user interface. But before that, I want to show you the batch portion of it, so you know, you once we start talking about the Rust and the batch, you know where the batch is coming from. So that's what I'm doing here. So basically you need two files. You need a listener and you need a sender. If I open my Raspberry Pi, right now I'm connected to a Raspberry Pi, and I'm not going to be going over how to connect to a Raspberry Pi. I'm assuming that you know how to do that. I have tutorials where I show you how to do what I'm doing right now. I'm using SSH just because I want to show you through the X, so you can see something to see, because I have a Pi that is headless. So this is the only reason that I'm doing this. So you are able to see it. So I'm going to now SSH into the Pi. All I'm going to do is SSH X. For you, if you're Unix based, you know what I'm talking about. That's the X server. That's what this guy is, X quartz. If you're on anything Unix based, I believe everything, all of them have them. Pi, that's the name of my Pi. I never changed the name, and that's the IP address that I'm going to go into. I need a password, so I'm going to put a password, and now I open a second. Now I open a second one. So I want to show you, I want to have two open because that way I have more flexibility going back and forth. So look at this right now. This is the client, because this is the one that is going to be doing the sending right now. And my terminal cursor here, this is going to be the listener. So this is the listener file. And if we go into the Raspberry Pi, and then we navigate to that directory where I have the stuff, I think I called it that. And then this is inside my Pi. So if I go into the source file, and let's open, and here it is. Let me make this a little bit bigger so you're able to see it, and make it a bigger. Okay, so I want to make it nice and big so you can read with me, because I'm going to be showing you. So I'm going to clear this. As you can see, before I clear it, I have a Pi listener and I have a Pi sender. Okay, right now I'm going to be showing you the sender, how to send images from the Pi into our computer. If you've worked with Pis before, or you work with some embedded systems, you know that sometimes like this can be a pain in the butt. Sometimes, yes, you can use SCP, and I'll show you. So you'll see. I don't want to spoil the surprise here. So let's clear it, and let's do nano pi image sender sh. And this is the script. If you're familiar with Unix or Unix-based systems, you can do this line by line, but I put everything on a script, so that way you are able to just hit enter and it executes. So let's go over it because this is going to be very similar to the listener. So if we spend some time on the sender, we don't have to spend that much time on the listener. So basically, it's just the shebang, uh, just any batch file. Here is checking for the command line arguments to make sure that is at least two because it's going to be looking for the file name and the target, which will be the IP address and the port wherever you're trying to connect to. We're going to here this the image. Basically, the first argument is assigned to image. The second argument is assigned to the target, which will be the IP address. Here we're just making sure that there is an image, that this contains something, and if it doesn't contain something, it's going to throw an error and exit. We keep going down. We're creating the working directory. It's going to be temp because like I said, we're using a PPM temporary intermediary while we make the transfer. So that's why that temp file is there. So it's going to just regular command, make dir, work directory, and the permissions. Okay. We keep going down. Here is displays the file, the name, what type is it? Is it a PNG? Is it a um, it checks if the file exists, and also where is it? Contains. I went too far. Image. Here's getting the image dimensions. It's making sure that it uses identify from ImageMagick in order to know what the dimensions are for the width and the height. That's doing there. And as we continue, we're going to see if there, for example, if there are no dimensions here, the command is going to fail. So it's going to exit. That's what's going on here. It's just making sure there's something there. Here we're extracting the width and extracting the height for the dimensions. And here is where we start using PPM as an intermediary file. So as you can see, we're creating a PPM file. We did that in the last tutorial. I'll show you how to work with PPM files. This is where it's being created, and here is going to make sure that the PPM was successful, that the conversion was successful. If it's not, it's going to throw an error and it's going to exit. Okay. If it was successful, we're going to extract the pixel data. And if you remember, this is where the RGB data from the P6 header from the last tutorial that we were using. In this case, we want to skip the PPM header. So that's why here is jumping into the fourth line. So it's skipping the 3 lines because we don't want those first 3 lines. We don't want the header. We just want the pixel data. That's what's happening there. Here is just a word count to make sure that the data, because we need to know if we got enough data, we have the expected data that we were looking for. Because remember, there are 3 bytes per pixel, and it's width times height times 3, because remember, it's RGB, right? So here's going to be doing to make sure that if there is a difference, it's going to check whether from the row size not equal to the expected size. If that is the case, we're going to create the difference between the two. And it's going to print out into the terminals. It's going to echo it and tell you what's the difference. If the difference is not that large, if it's a small positive difference, right, we're going to pad it with extra zeros. And that's what's happening there. If you've done some other stuff, you know what I'm talking about, or just a matrix and you pad it with zeros, just as placeholders basically, and making it to whatever size you want. This is what we're doing here. Here we're actually adding it, and if it's too big, if it's greater than, here is less than 100, but if it's less than and it's a negative difference, then we're going to trim it, and that's what's happening here. And here's going to show the head, and it's going to change to the name from here into this name, right? From the image raw temp, it's going to become just image raw. This is going to contain all the raw data, okay? We continue. If it's neither of the two, it's going to say it's too small. So it's going to give you uh, something that said we cannot continue, basically. So we continue. It creates the binary header with the width and the height. It's going to be in liter endian format because, as you know, Raspberry Pi, some of these protocols use big endian. So I think the Mac, they all use liter endian, but some of the protocols are expecting big endian. So we got to make sure that we send this stuff in liter endian format, and that's why we're going through that step to make sure that this stuff is in liter endian format. We're going to print to create the binary header to make it pretty and to make it look the way it's supposed to look using hex. And now we're going to make sure that it was created correctly. Also make sure that the size is correct. Combine the header with the image into one single file. So it's going to have the header bin with all the raw stuff with the image raw stuff, and then it's going to concatenate into a transmit, and this is actually the stuff that we're going to transmit. And now it's going to say that it's going to retry 3 times because it might fail, let's say, 1 time, so you want to try at least 3 times. You can change that, that's up to you. And you can create other stuff. I'm trying to keep it simple. And then it's going to complain if the transmission, whatever happened, if there was not. I'm going to include this in my GitHub, so don't worry if you don't have right now, if you're not catching everything, we're going to do that. And then we're going to here make sure that just error handling stuff and making sure that one goes, if it didn't go 1 time, it's going to go another time and another time and another time. If not, it's going to exit. And that's basically what's happening from the Pi into our computer. So now I'm going to close here, and I hope I have some, oops, none of that stuff. I forgot the usage of it. I'm being lazy. I had to close everything because, yeah, these are all no. Because one of the ports I couldn't clear it, so I had to reboot. So I lost some of my stuff. Let's use here. I don't. This is that one. No, actually, that's the image listener. But we're not going to use that one. We're going to use. I'm just being lazy here. 1 second. And if we go here into the file here, there's the usage right there. So I'm just gonna copy that. And it's here, and it's basically, let's see. So it's there. So it's sudo image pi sender, and then it's going to be I'm sending an images, graphite, and then what's the usage? The target IP. So in this case, it will be 192.168.0.131, I believe. And it's going to be on port 2025. And then hit enter. Hopefully it will work. And there it is. It says that it went through, and boom, it received it already. And as you can see, that's the image. So it went from the Pi right into, and I'll do that again so you see how fast it is. Let me clear it so you see if I can type. So let's hit the same command again, and you're going to see it coming from the Pi into my computer, and it's almost instantly. And there it is. And that's the power of you don't you could have done this using SCP, but then you would have to send it, and then you would have to use a program to open the image and all of that stuff. Here it's just automatic. It's almost um, real time, and that's the beauty. This is with images, and you can do it. Like I said, this is coming from the Pi, because like I said, a lot of times that's the pain in the butt, is to get it from the embedded system into your computer. Coming from the computer is easy. All you need to do is send it. Instead of a listener, you're going to use a sender, and you send it that way. But remember, some of these, when you're using Raspberry Pi, remember, even though they're Unix based, the Mac, I'm using a Mac right now, and Raspberry Pi is using Debian. They are Unix based, but remember, some of the times the names will change. So in our case, they, for example, especially when you're dealing some of the names, you might need to change them. And sometimes they handle files differently. These are just a few examples, just to give you an idea. But keep an eye on those. I'm not want to make this tutorial too long, so I'm going to end it here. In the next tutorial, we're going to be doing some other cool stuff and how to send images from one to the other. This is the end of this tutorial. If you like this tutorial, please click the like box, subscribe to my channel, and I will see you next time. Take care.